Hello everyone, welcome back to Ani's MLT. Today we are going to learn about history of microscope. Why was microscope important? ಮೈಕ್ರೋಸ್ಕೋಪ್ ಇವೆಂಟ್ ಆಗದೇ ಇದ್ದಿದ್ರೆ ಸೈಂಟಿಸ್ಟ್ಗೆ ಸೆಲ್ಸ್ ಬಗ್ಗೆ ಗೊತ್ತಾಗ್ತಿರ್ಲಿಲ್ಲ, ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ ಬಗ್ಗೆ ಗೊತ್ತಾಗ್ತಾ ಇರಲಿಲ್ಲ, ಬ್ಲಡ್ ಸೆಲ್ಸ್, ಡಿಸೀಸ್ ಕಾಸಿಂಗ್ ಮೈಕ್ರೋ ಆರ್ಗಾನಿಸಮ್ಸ್ ಬಗ್ಗೆ ಕೂಡ ಗೊತ್ತಾಗ್ತಾ ಇರಲಿಲ್ಲ. ಸೊ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಈಸ್ ಒನ್ ಆಫ್ ದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇನ್ವೆನ್ಷನ್ ಇನ್ ಸೈನ್ಸ್ ಅಂಡ್ ಮೆಡಿಸಿನ್. ಮೈಕ್ರೋಸ್ಕೋಪ್ ಹಿಸ್ಟ್ರಿ ಡೈರೆಕ್ಟ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗಲ್ಲ. ಅದಕ್ಕೂ ಮುಂಚೆ ಮ್ಯಾಗ್ನಿಫೈಯಿಂಗ್ ಗ್ಲಾಸಸ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ರು. ಲಾಂಗ್ ಬ್ಯಾಕ್ ಪೀಪಲ್ ನೋಟಿಸ್ ದಟ್ ಕರ್ವ್ಡ್ ಗ್ಲಾಸ್ ಥ್ರೂ ನೋಡಿದಾಗ ಆಬ್ಜೆಕ್ಟ್ ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತೆ. ದಿಸ್ ಐಡಿಯಾ ಆಫ್ ಲೆನ್ಸಸ್ ಲೇಟರ್ ಬಿಕೇಮ್ ದ ಬೇಸ್ ಫಾರ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಡೆವಲಪ್ಮೆಂಟ್. ಸೊ ಹಿಸ್ಟ್ರಿ ಸ್ಟಾರ್ಟ್ಸ್ ವಿತ್ ಲೆನ್ಸಸ್ ಅಂಡ್ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್. ನೌ ದ ರಿಯಲ್ ಸ್ಟೋರಿ ಬಿಗಿನ್ಸ್. Around 1590, Dutch spectacle maker named Zacharias Janssen and his father Hans Janssen are believed to have made the first compound microscope. What did they do? Yes, ಅವರು 2 lenses ಯೂಸ್ ಮಾಡಿ ಒಂದು ಸಿಂಪಲ್ ಡಿವೈಸ್ ತಯಾರು ಮಾಡಿದ್ರು. ಆಬ್ಜೆಕ್ಟ್ ಒನ್ ಸೈಡ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಲೆನ್ಸ್ ಮೂಲಕ ನೋಡಿದಾಗ ಅದು ಮ್ಯಾಗ್ನಿಫೈ ಆಗಿ ಕಾಣಿಸುತ್ತೆ. Why is it called compound microscope? Because it uses more than one lens, usually objective lens and eyepiece lens. So remember, 1590 Zacharias Janssen first compound microscope. Although ಅದು modern microscope ಥರ perfect ಆಗಿರಲಿಲ್ಲ, it was the starting point. After Janssen, another important name is Galileo Galilei. Around 1609 to 1610, Galileo improved lens instruments and made an instrument called occhiolino, which worked like an early microscope. His contribution, improved lens arrangement, helped in early microscope design, supported the idea that lenses can reveal tiny structures. So, microscope development was not one person's work only. Many scientists improved it step by step. Robert Hooke. In 1665, Robert Hooke published a famous book called Micrographia. In this book, he described many objects seen under the microscope. He observed a thin slice of cork under the microscope. What he saw were tiny box-like compartments. These small compartments reminded him of rooms in a monastery, so he called them cells. He improved the microscope observation. He published detailed microscopic drawings. He gave the term cell. Antonie van Leeuwenhoek. He was a Dutch scientist and lens maker. Around the 1670s, Leeuwenhoek made very powerful, simple microscopes. Though they had only one lens, the quality of that lens was excellent, and magnification was much better than many microscopes of that time. He observed bacteria, protozoa, sperms, red blood cells, microorganisms in pond water. He called these tiny living organisms animalcules. He was one of the first people who actually see living microorganisms. That is why Antonie van Leeuwenhoek is called the father of microbiology. After Hooke and Leeuwenhoek, microscope development continued slowly. But there was a major problem in early microscopes: poor image quality. The image often looked blurred, colored at edges, not very sharp. So scientists had to improve the lens further. Scientists and lens makers tried to improve clarity of image, magnification, focusing system, brightness, lens quality. The 19th century was a turning point in microscope history. Many improvements happened in lens quality, illumination, focusing, stage design, resolution. Joseph Jackson Lister. He improved microscope lenses by reducing optical defects. His work helped in making clearer and sharper images. Why was this important? Because microscope is useful only when the image is clear. If image is blurred, scientists cannot study cells and microorganisms properly. So Lister's improvement made microscopes more reliable for scientific study. As years passed, microscopes became more advanced. Scientists added better objective lenses, coarse adjustment and fine adjustment, improved mirror or light source, stronger body and stage, better focusing mechanisms. This gradually led to the modern compound microscope that we use in laboratories and colleges today. Microscope history is closely connected with cell biology. Because of microscope, scientists understood living organisms are made of cells. Cells are the basic structural unit of life. New cells come from pre-existing cells. So microscope didn't just help in seeing objects. It changed our understanding of life itself. Now think from MLT point of view. If microscope had not developed, medical laboratory science would be incomplete. Microscope made it possible to study blood cells in hematology, bacteria in microbiology, parasites in stool or blood, urine sediments, tissue sections in histopathology, fungal elements, semen analysis, abnormal cells and infections. So in MLT, microscope is not just an instrument. It is a basic foundation of diagnosis. Now, scientists wanted to see even smaller structures than what light microscope could show. Normal light microscope has limitations. Very tiny structures like viruses and cell ultrastructure cannot be seen clearly with ordinary light microscope. So in 20th century, a new breakthrough happened. Electron microscope. A major advancement came in 1931 when Ernst Ruska developed the electron microscope. Instead of visible light, electron microscope uses beam of electrons. This gives much higher magnification, much better resolution. There are two types. One, transmission electron microscope, and the second one, scanning electron microscope. What could scientists study with electron microscope? With electron microscope, viruses, cell organelles in details, mitochondria, ribosomes, ultrastructure of cells, surface details of microorganisms and tissues. So, this was a huge revolution in biology and medicine. Today, microscope technology has advanced a lot. Now we have compound microscope, stereo microscope, fluorescence microscope, phase contrast microscope, dark field microscope, electron microscope, and digital microscope. These microscopes are used in education, research, medical diagnosis, pathology labs, microbiology labs, biotechnology, forensic science. So, from a simple lens to highly advanced digital and electron microscopes, the journey of microscope is truly amazing. So, students, history of microscope is not just about dates and names. It is the story of how humans slowly opened the door to the invisible world. From a simple lens to seeing cells, to discovering microorganisms, to studying viruses and cell organelles. Microscope completely changed biology, microbiology, pathology, and medical laboratory science. As MLT students, when you hold a microscope in your hand, remember you are using an instrument that changed the history of medicine. So, dear students, if you understood this topic, don't just memorize it. Visualize the journey from lens to laboratory science. That is the best way to remember. In Ani's MLT, my goal is simple: to make difficult MLT subjects easy interesting, and unforgettable for every student. If you want more classes like this on microscope types, parts of microscope, uses, care and maintenance, hematology, microbiology, biochemistry, and all MLT subjects, then subscribe to Anis MLT right now.